In the still silence of the cosmos, something stirs not, a star, not a particle, but a thought. What if the thing we call consciousness isn't just born from the brain, but stitched into the very fabric of space-time itself? Imagine a universe not merely aware of us, but aware through us. Across quantum voids and black hole horizons, patterns emerge that defy randomness, patterns that remember. What if space-time isn't the stage, but the player? And what if you watching this are part of its unfolding story? This isn't science fiction. This is where physics begins to whisper secrets no telescope can see. Subscribe if you believe consciousness might be more than neurons, more than flesh. Join us as we descend into one of science's most mind-bending frontiers. This journey might change you. It began not with a telescope, but with a question. In 1991, Sir Roger Penrose, a Nobel Prize-winning mathematician and physicist, released a book that many in the scientific community called dangerous, not because it was reckless, but because it dared to trespass the emperor's new mind. Asked something so radical it almost sounded like science fiction. What if consciousness wasn't computational? What if the human mind wasn't a glorified calculator, but a quantum phenomenon? Penrose wasn't a mystic. He had worked alongside Stephen Hawking. He had given the world insights into black holes and singularities. But this question, this notion that human consciousness might arise from something deeper, stranger, and more elusive than mere neural computations, set the stage for one of the most controversial scientific ideas of the modern age. At the heart of his theory was something called ORCA, for orchestrated objective reduction. It was a collaboration with Dr. Stuart Hameroff, an anesthesiologist who believed the clues to consciousness weren't in the mind's electrical signals, but in its cellular skeleton. Hameroff had spent years studying microtubules, tiny filament-like structures within our brain cells. He was fascinated by their precision and order, how they vibrated, how they structured the very architecture of consciousness. Could these be the quantum engines inside neurons? Could the brain be using quantum computation, entangled not just with itself, but with the very fabric of reality? It was a theory almost everyone hated. Neuroscientists called it speculative. Physicists dismissed it as fanciful. But the question lingered, because no one, not even the most advanced AI, could replicate the thing we take for granted: subjective experience, the feeling of I, the inner movie only you can watch. And here's where it gets stranger. Quantum mechanics has a peculiar trait: it's observer-dependent. A particle exists in multiple states until it is observed, until someone collapses the wave function. But who or what counts as an observer? And could consciousness itself be the thing the universe requires to become real? Penrose and Hameroff weren't suggesting brains cause reality. They were saying consciousness may arise from a type of collapse that isn't random, one that happens inside space-time geometry itself, like a quantum thought echoing across the fabric of the cosmos. It's a staggering idea, that your awareness might not be separate from the universe, but a pattern within it. Not data on a brain, but behavior of space-time. Let's stop here. For a moment, look around you. The light hitting your eyes, the sounds entering your ears, the thoughts forming in your mind. What if all of that isn't just happening inside your head, but is co-arising with the structure beneath reality itself? What if your consciousness is like a wave cresting on an ocean of space-time, temporary, local, yet drawn from something eternal? In 2006, quantum physicist Henry Stapp revisited Penrose's ideas. He didn't fully agree, but he did admit, if consciousness does involve quantum mechanics, then it changes everything about how we understand the mind, because it would mean your decisions aren't just the product of cause and effect. They might be connected to the universe's deepest rules. Still, most of science pushed back. Microtubules are too warm for quantum coherence, they said. The brain's too noisy. Entanglement can't survive in such conditions. But in 2013, something unexpected happened. A group of researchers discovered that quantum coherence had been observed in warm biological environments, in bird navigation, in photosynthesis, and even in olfactory receptors. The barrier that once seemed to protect neuroscience from quantum theory began to crack. Suddenly, Penrose and Hameroff didn't look so absurd. Suddenly, it seemed possible that some part of the brain, those zippertubules, those delicate scaffolds, could maintain coherence, just long enough to produce a moment of conscious thought, not a simulation, not a side effect, but a phenomenon one. That might ripple across space-time. The implications are almost unfathomable. If consciousness is a quantum effect, then it might be fundamentally connected to the geometry of reality. It might mean that every act of awareness, every dream, every pain, every choice is a quantum event embedded in the very structure of the cosmos, like a note in a grand, vibrating field. And yet, most of this remains in the shadows, relegated to fringe discussions, whispered at conferences, debated in long, tense peer reviews, because science moves slowly, and because the idea that you might be more than flesh, more than data, still terrifies many. But the dream has been planted, and as more physicists begin to flirt with the idea that space-time itself may not be fundamental, that maybe even space and time emerge from something deeper, raises the most provocative question of all. What if consciousness is not an emergent property, but a source code? What if it's not born from the universe, but the reason the universe exists at all? In the early morning chill of Princeton, New Jersey, tucked away behind the ivy-laced halls of the Institute for Advanced Study, a small team of physicists gathers around chalkboards, scratching out equations, not to understand particles, but to decode the canvas beneath them. To these researchers, space-time isn't a void. It's not emptiness. It's not nothing. It's structure, shape, memory, and like the skin of some colossal, sleeping creature, it may hold hidden scars, subtle indentations where something has passed through. Something that felt. At the center of this paradigm shift is an idea that sounds simple, but rewrites reality. The holographic principle, first whispered in the 1990s by physicists Gerard T. Hooft and Leonard Susskind, and inspired by black hole thermodynamics, the principle proposes something radical: that everything we perceive in 3 dimensions, our bodies, our cities, even galaxies, might actually be encoded on a distant 2-dimensional boundary, like a cosmic projection, a 3D movie cast from a 2D screen beyond space. Imagine holding a snow globe. Now imagine that the entire snowy world inside the people, the weather, even time itself as a projection, created by code on the glass exterior. What if we're living inside that globe? In this view, reality is not made of atoms, but information. And that information doesn't live inside space, it generates space. But here's the twist that leaves physicists staring into space at 3 a.m., coffee gone cold. If the universe is a hologram, and if information constructs the stage we call space-time, then consciousness, which processes, interprets, and even alters information might be woven into that architecture. Let that sink in. What we think of as our mind, our thoughts, emotions, dreams may not just be responding to the universe, but participating in its creation. Not spiritually, but structurally. Dr. Juan Maldacen, a theoretical physicist also based at Princeton, developed one of the most compelling versions of this idea, the ADS-CFT correspondence. In short, it's a mathematical proof that a gravity-based universe in higher dimensions can be exactly equivalent to a quantum field theory on its lower dimensional boundary. It's as if gravity and quantum physics, two bitter rivals in physics, suddenly began whispering the same language, just on opposite sides of a veil. So what lies beneath this veil? Some physicists now speculate that space and time might not be fundamental at all, that they emerge from a deeper network of quantum entanglements, correlations between particles that persist across distance, and possibly across dimensions. Picture spacetime not as a grid, but as a web. And each connection in that web isn't a distance. It's a relationship, a link, a memory, a story. And in that story, consciousness may not be a passive character. It may be a co-author. This brings us to a startling crossroad. If space-time is made of information, and information is processed by minds, could there be feedback between consciousness and the geometry of the universe itself? Could your awareness, your attention shape the web beneath your feet? What would that mean for free will, for perception, for death? These aren't just poetic questions, they're active frontiers of physics. In 2020, a team of researchers, led by Netta Engelhardt and Aaron Wall, explored the concept of entanglement wedges, regions of space that only become defined when certain bits of information are known. In other words, parts of space-time might only exist if they are being observed, or, at least, entangled with an observer. Now ask yourself, are you observing the universe, or is it completing itself through your observation? Here's where it gets even stranger. If our universe is a hologram, and consciousness is entangled with the structure of space-time, then we might be echoes, not illusions, but reflections of something deeper. And if that's true, if you are a projection, the question is, from what? Is there a higher dimensional source where minds and matter are united, where time flows differently, where your consciousness, instead of being confined inside a skull, is part of a vast, distributed system? Some physicists call it the bulk, others the source code, but all of them are pointing to one haunting possibility, that the deeper you look into the nature of space-time, the more it begins to remember you back. The very act of inquiry might echo across its structure. The questions you ask may define the shape of the answers, like footprints shaping the path. So take a moment. What if your memories, your fears, your hopes aren't just chemical reactions, but coordinates? Points in a map, not of the brain, but of space-time's geometry. Would that mean your experiences matter more than we ever imagined? Could we someday read consciousness from space-time like decoding a song from ripples in a pond? These aren't answers we have yet, but the shadows are moving, and somewhere beneath the skin of reality, the pattern begins to stir. It was a cold spring in Vienna when Anton Zeilinger's lab achieved something that should have been impossible. Two particles, separated by kilometers, seemed to influence each other instantly, not by waves, not by force, but by observation. What the physicists measured in one place determined what existed in another. It was called quantum entanglement, but what truly unsettled the world wasn't the connection between particles, it was the role of the observer. For over a century, quantum mechanics has whispered something disturbing, that reality, at its most fundamental level, doesn't truly exist until it is measured, until someone looks. This idea was once thought to be philosophical fluffer, quirky interpretation, but experiment after experiment reinforced the mystery. Electrons don't go through one slit or another, they go through both, as waves. We measure them. The instant we look, they choose. As if our gaze collapses possibility into fact. But what is an observer? Physicist John Archibald Wheeler called it the participatory anthropic principle. In his view, the universe isn't a passive, objective system, it's a quantum device that needs observers to actualize reality. No phenomenon is a real phenomenon, Wheeler said, until it is an observed phenomenon. Let's pause and reflect on that. You, watching this, may think you're small, one consciousness in a vast, indifferent cosmos. But what if your very act of awareness is completing the universe around you? Not metaphorically, mathematically. Here's the uncomfortable possibility. Consciousness isn't just seeing reality, it's choosing from among its possible outcomes. In Wheeler's famous thought experiment, the delayed choice, quantum arrays seemed to decide retroactively whether they behaved like waves or particles, based on whether the observer would learn their path later. Time, causality, even logic itself fall bent around the act of observation. So again we ask, what is consciousness doing? Could it be more than just a bystander? Could it be the mechanism through which space-time, energy, and probability become real? This is no longer just philosophical musing. A group of researchers at UC Berkeley ran an extended version of the double-slit experiment using conscious intention. They found slight statistical deviations when participants focused their awareness on the quantum system. The results were controversial, reliable maybe, but they suggested something extraordinary, that perhaps the observer matters. Still, the scientific community pushes back. Rightfully so. Extraordinary claims require extraordinary evidence. But as we dig deeper, we're forced to ask, if not consciousness, then what causes the wave function to collapse? Because physics can't avoid the observer. It's baked into the equations. Schrödinger's cat is both alive and dead, not metaphorically, but mathematically, until someone opens the box, until an experience happens. And if that experience must occur for the system to resolve, then experience consciousness might be more foundational than particles, or space, or time. What if reality is not composed of things at all, but interactions, and consciousness is the most refined interaction of all? Some physicists now propose that what we call the self is simply a localized feedback loop in a vast quantum network. Not separate, but entangled. Not accidental, but necessary. And it doesn't end with particles. In 2018, a team from the University of Chicago published a paper exploring quantum cognition. The idea that certain decision-making processes in the brain mirror the probabilistic behavior of particles. Your mind, in other words, may already be using the logic of quantum systems, not metaphorically, mechanistically. This opens a door so big it's almost frightening. If your thoughts operate quantumly, and quantum events require observation to collapse, then consciousness may be both cause and consequence of the universe's unfolding. Think of it like a cosmic feedback loop. Consciousness observes reality, collapsing possibilities into facts. And those facts then evolve consciousness, over and over, like a spiral growing inward and outward, shaping galaxies, shaping minds. And that leads us to a chilling question. If no one were to observe the universe, would it exist? Some say yes through decoherence, through environmental entanglement. Others say no, that until experience happens, there is only probability, not reality, but either way, the observer illusion remains, because if we're not passive spectators, but essential participants, then the cosmos may not be a thing that exists. Out there it may be something we co-create every instant with our awareness. Think of this: the next time you gaze at the stars, those photons traveled billions of years to reach your eye, but only when they struck your retina did they become relocked into history. Until then, they were probability waves. Potential, possibility. You, in looking up, finalized their journey. You completed the story, so ask yourself, when you stare into the night sky, are you observing the universe? Or is the universe finishing itself through you? Because perhaps the observer isn't an illusion after all. Perhaps it's the only real thing that ever was. In the winter of 2014, cosmologist Max Tegmark walked onto a TED stage and said something that made physicists and philosophers sit forward in their chairs. Consciousness, he declared, is a state of matter, not an emergent illusion, not a ghost in the machine, but a real, measurable, physical phenomenon, just like ice, water, or steam. He called it PERCEPTRONIUM. The idea was bold, that certain arrangements of matter, when configured with enough complexity, integration, and feedback, don't just compute, they feel, they generate subjective experience. Consciousness, in this view, is not magic, it's physics, not separate from the universe, but one of its phases. Imagine the universe as a cosmic crystal, shifting between states. Under certain pressures, matter becomes solid. Under certain conditions, it becomes alive. And when complexity hits just the right frequency, it becomes aware. But where is the line? What's the threshold between matter that obeys and matter that knows? Tegmark's theory draws from integrated information theory, IIT, developed by neuroscientist Giulio Trononi. IIT proposes that consciousness corresponds to the degree of integrated information in a system, denoted by a value called phi. The higher the phi, the more conscious the system. A rock, low phi, a thermostat. Some, a human brain. Enormous. But here's where the mirror cracks, because according to IIT, consciousness doesn't care what something is made of. A brain, a silicon chip, even a network of quantum fields, if it has the right structure of integrated information. It experiences. So what about the universe? If space-time is structured, if it's stitched together by relationships, symmetries, and entanglements, could it, under certain conditions, meet the criteria for consciousness? Could the universe be having a subjective experience? Not metaphorically, literally. This is not idle speculation. Some researchers, like physicist Sean Carroll, explore models where the fabric of spacetime emerges from entanglement, meaning spacetime doesn't contain information, is information, and information that interacts, evolves, and self-integrates. Could, by Tegmark's standard, qualify as %RON. In this light, black holes become fascinating mirrors. They're not just gravity wells, they're maximal information objects. They store data on their event horizons. They have entropy. They even obey thermodynamic laws. Could they be, in some sense, conscious? Let that idea breathe. What if? A black hole isn't just a dead star, but a different mode of awareness. A sealed chamber where time dilates and memory persists. Of course, Many physicists reject this idea. There's no evidence, they say. Consciousness leaves no trace on an equation. It cannot be measured, so it cannot be real. But that objection, the inability to measure subjective experience, is precisely what makes consciousness so slippery. You can't see a thought, you can't weigh an emotion, but you can feel them. And that feeling, the first-person view, is the one piece of reality you can never doubt. It's the mirror through which all science is done. So what happens when the mirror starts to reflect you? In a lab at the University of Wisconsin, Tonani's team attempts to measure consciousness using phi, patients under anesthesia, sleep, or in coma states show a drop in integrated information. When they regain consciousness, phi rises. Not instantly, gradually, like light through fog. But the human brain is just one laboratory. What if space-time itself has regions of high phi? Places where complexity condenses, where fields converge, where geometry becomes aware of itself. Could galaxies be like neurons, vast islands of information, slowly coalescing into patterns too large for us to see? And if so, could Earth be in one of those patterns? Imagine your thoughts aren't just yours. They're part of a field, a flow, a feedback loop of the universe observing itself. You are a node processing point in a conscious cosmos. Does that feel absurd? Or does it feel strangely familiar? Ancient traditions have long whispered that the universe is alive, that stars are beings, that consciousness is not born from matter, but the other way around. Science rejected these views. But now, through mathematics and measurement, we return full circle to an idea once called mystical. And here's where things get intimate. If you are part of a conscious universe, then every decision you make sends ripples. Every act of kindness, cruelty, creativity shapes the feedback loop. You are not separate. You are participating. So, how do you live inside a cosmic mirror? Do you pretend it's all random? Or do you accept the possibility that your choices matter more than you know? Tegmark himself admits we are only at the beginning. We don't yet have a complete theory of consciousness. We don't yet know what space-time really is. But he urges us not to turn away. We must dare, he says, to ask the biggest questions. So we ask, if consciousness is a state of matter, could space-time itself, under the right conditions, wake up? And if it already has, would we even know? Far beneath the scale of atoms, beyond even the tiniest known particles, lies a realm where the rules of physics begin to break down, a realm known as the Planck scale. It's here, in this unimaginably small space, where the smooth fabric of space-time disintegrates into something wild, jittery, and chaotic. Physicists call it quantum foam, churning sea of tiny fluctuations, bubbles of geometry popping in and out of existence, a trillion times per second. To most, this seems like noise, background static, but to a new generation of theoretical physicists, it might be code, and within that code could be the first hints of consciousness, written directly into the blueprint of reality. The theory begins with loop quantum gravity, a daring attempt to unify general relativity with quantum mechanics. Unlike string theory, which imagines vibrating strings, loop quantum gravity proposes that space-time itself is made of tiny, discrete chunks, quanta of space. These chunks aren't located in space. They are space. Imagine a digital screen. Up close, it's made of pixels. No matter how vivid the image, it's just a pattern of discrete units. Similarly, loop quantum gravity suggests that space-time isn't continuous, it's composed of tiny loops woven into intricate structures called spin networks. These networks are not static. They evolve. They compute. Some physicists liken them to quantum circuits processing relationships, storing information, shaping geometry. And here's where the mystery deepens, because if spacetime is made of evolving networks of information, then it's not a stage, it's a machine, and machines, when arranged with enough complexity, can generate unexpected behavior, emergence, memory, awareness. In 2018, researchers from the Perimeter Institute and the University of Waterloo published papers exploring how space could emerge from entanglement patterns in these spin networks. They found something shocking: coherence, patterns that held together across transformations, like threads through a turbulent current. It was as if the network remembered, and memory implies state, feedback, a kind of IOR-ITY. Could this be the first glimmer of a mind-like property inside spacetime? Let's reframe the question. In the brain, consciousness is believed to emerge from a network of interacting neurons. But what really matters isn't the neurons themselves, it's the structure of their interactions. The timing, the connectivity, the resonance. Now replace neurons with quantum loops. Replace chemical signals with gravitational information. Replace synapses with entanglement. What if the fabric of the cosmos is not just a thing, but a process? A process capable of experience, of memory, of qualia. It's speculative, yes, but not impossible. Because even in our own brains, we don't know what consciousness is. We know which regions activate. We know how damage changes perception. But no scan has ever shown awareness. No equation yet explains why it feels like something to be you. And if we can't explain it in ourselves, how can we be sure it isn't happening elsewhere? In the foam, perhaps. Think of it this way. If you drop a pebble into a still pond, ripples spread. But what if the pond remembers the ripples long after they're gone? What if spacetime, beneath its apparent silence, retains echoes of every interaction that has ever occurred? Not metaphorically. Structurally, it might sound like fantasy. But recent work in quantum information theory suggests that information cannot be destroyed, ever. Not in black holes, not in cosmic collisions. This means the universe is, in some sense, a memory engine accumulating, recording, evolving. And where there is memory, perhaps there is awareness. Perhaps consciousness is not a latecomer to the universe. Perhaps it's an intrinsic property of this quantum foam arising in patterns too small and fast for us to detect, but just real enough to influence the geometry of everything that follows. The philosopher Alfred North Whitehead once said, "Reality is not made of things, it is made of events." Modern physics seems to agree, and the smallest events, the jittering shifts in the loops of space, may be the sparks of something vast and hidden. But how would we know? How do we detect a consciousness that doesn't look like ours, that doesn't think in language or images, but in spin and symmetry? Could a region of space-time prefer certain evolutions? Could it respond to intention, pattern, focus? There are no definitive answers yet, but the questions are growing louder, and in a lab in Italy, researchers using atom interferometry are attempting to detect quantum gravity, directly probing the foam for signs of coherence, for patterns that shouldn't be there. What if they find something? What if the fabric of reality, when observed closely enough, begins to speak? It won't be a voice, not in the way we understand it, but a correlation, a resistance, a presence. And if that presence is confirmed, even faintly, it would mean that the quantum foam, once thought to be chaos, is something else entirely. A mirror humming with intention. In 2016, neuroscientist Dr. Henry Markram stood before a crowd in Switzerland, pointing to a visual that looked like a sci-fi cathedral, shimmering towers of color, latticed tunnels of energy, and swirling multidimensional shapes. But this wasn't art. This was a simulation of a human brain firing, thinking, being, and buried within that chaos was a pattern. Something strange had emerged from the data as the brain engaged in thought. Neurons weren't just lighting up randomly, they were forming geometric structures. Simple at first, lines, triangles, then more complex, cubes, tesseracts, seven-dimensional polytopes. The higher the level of consciousness, the more intricate the shape. And when consciousness ceased during sleep, anesthesia, or seizures, shapes collapsed, folding in on themselves like paper under fire. It was the first time scientists had seen topological spaces, mathematical shapes that exist in more than 3 dimensions, forming inside the brain in real time. So what does this mean? It suggests that the brain doesn't just process information. It builds geometry. If thought is a kind of architecture, and consciousness is the act of stepping inside. This was the birth of a new field, algebraic topology in neuroscience. And it triggered a question that's still rippling through the scientific world. If consciousness builds geometry inside the brain, could it also interface with the geometry of spacetime itself? Let's break that down. In classical neuroscience, consciousness is the result of billions of neurons firing in patterns, electrical and chemical pulses, forming loops of activity. But these new models suggest the real story isn't just in where neurons fire, but in how their connections shape the space they occupy. In short, your mind might not be confined to a region of the brain, but to the shape those regions form when activated, and this shape can be modeled, measured, and studied. A team at the Blue Brain Project discovered that thoughts could be represented as cliques, clusters of neurons interacting in precise configurations. These cliques didn't just form chains, they formed higher dimensional Think of them as thought sculptures, evolving in real time, vanishing as quickly as they arise. But here's where things get cosmic. These same geometric patterns, multidimensional simplicize, so appear in theories of loop quantum gravity. In string theory, even in tensor networks, modeling spacetime emergence. They are universal structures, appearing in vastly different systems. So we must ask, is this a coincidence? Or is consciousness simply tuning into a structure that already exists? Imagine your brain as a tuning fork. It resonates with patterns. And those patterns, when they hit a certain frequency or form, produce experience. Now imagine spacetime as another tuning fork, vibrating with its own deep geometry. What happens when those two geometries align? Could that be what waking up feels like? There's another layer. Some physicists, like Dr. Lenny Susskind and Dr. Brian Greene, suggest that entanglement patterns, the invisible threads connecting particles across distance, may create the shape of space itself. These patterns don't exist inside space. They are space, so when your brain forms entangled, integrated networks, might it be briefly syncing with the deep grammar of the cosmos? It's not a new idea. Mystical traditions for centuries have described the body as a microcosm, a miniature version of the universe. Perhaps they were intuiting what science is only now beginning to glimpse. That thought doesn't float above physics. It is physics structured, dimensional, and happening in form. Let's return to the lab in one experiment. Participants were given simple visual stimuli, flashing lights, shapes. As they processed these inputs, their brains formed low-dimensional geometries, lines, loops. But when asked to reflect, to imagine, to self-generate thought, the shapes exploded in complexity, climbing to 11 dimensions and beyond. In other words, self-awareness creates the richest geometry of all. Why does that matter? Because if consciousness maps to geometry, and if space-time is a geometric structure, then it's possible, just possible, that these systems can interact, that the architecture of your thoughts can resonate with the architecture of reality. And if that's true, then consciousness isn't just in the brain, it's between the brain and space-time, bridged at, a feedback loop, a conversation. Let that settle, what you experience as you, your stream of thought, your inner voice, your sense of now may be. The dance between two geometries, one biological, one cosmological. And when the alignment is right, experience happens. When the shape collapses, consciousness fades. And here's the haunting question. Could there be other configurations? Other minds built not in brains, but in stars, in dark matter, in fields of space-time geometry we haven't yet imagined. Is your consciousness just one dialect in a much larger language? So next time you close your eyes and feel yourself thinking, imagine a spark in the dark. Imagine a cathedral of geometry, rising silently from the foam of your neurons, echoing into the structure of the universe itself. It begins with a fading heartbeat, a final breath. The synapses fire one last time, then silence. To most, death is the end, the dissolution of the self, the unraveling of thought into nothingness. But what if that silence isn't truly silent? What if consciousness, like light, doesn't vanish, but transforms across hospitals and hospice wards? Something strange has been whispered for decades. Accounts of near-death experiences and DEs, people clinically dead for minutes, even hours, returning with vivid stories of tunnels, lights, life reviews, presence. Most scientists dismiss these as hallucinations, byproducts of a starved brain gasping for order, and yet patterns persist. Dr. Pim van Lommel, a Dutch cardiologist, studied hundreds of these cases. In a groundbreaking 2001 study published in The Lancet, he found that patients with flat EEG detectable brain activity reported coherent, structured experiences, not confusion, not dreams, but lucidity, awareness, memory. So, the question emerges, where was the information stored? If the brain was offline, what was doing the thinking? This question strikes at the core of neuroscience, because we've long assumed that consciousness is generated by the brain, that when neurons stop firing, the mind disappears. But what if that's not entirely true? What if consciousness is not produced by the brain, but channeled through it, like a radio receiving a signal, not the origin of the music, but the interpreter? If that's the case, then death may not be destruction. It may be tuning, a change in frequency, a collapse of one interface, revealing another. Quantum biologists are beginning to explore this frontier. Researchers like Dr. Stuart Hameroff believe that microtubulous structures within neurons are involved in quantum-level processing. When the body dies, these structures break down, but the quantum information inside them, according to the principles of physics, cannot be destroyed. It must go somewhere. Hameroff and Penrose propose that this quantum information may dissipate into the fabric of space-time, remaining coherent in some form within the quantum field. Not a ghost, not a soul, but a field. imprint an echo in the structure of reality itself. This is where death becomes a paradox, because if consciousness can survive, even momentarily, outside the brain, then it may not be tied to matter in the way we thought. It might be entangled with space-time, integrated with geometry, like a ripple left in the pond long after the stone has sunk. Let's explore a deeper analogy. Imagine your life as a laser beam, narrow, bright, coherent. When you die, that coherence scatters. But the light doesn't disappear, it diffuses, it rejoins the field. Could consciousness behave the same way? If space-time has memory, if the quantum foam stores information, then perhaps death is not erasure, but reconfiguration. Physicist and information theorist Dr. Vlatko Vedral has proposed that quantum information is the true substrate of reality, not matter, not energy. But Bitscube is encoded into the structure of the cosmos. If so, then your consciousness, as a unique pattern of information, may be more fundamental than the atoms that hold it, and information, as Stephen Hawking famously realized, cannot be lost even in black holes. So what happens to the you that was? Do you dissolve? Do you persist? Or does the universe remember? Consider this. In Tibetan and Egyptian death texts, ancient sages wrote of the transition period between death and rebirth, a zone of passage, a liminal state, what they described floating awareness, hyperreal perceptions, dissolution into light mirrors. Modern end accounts with uncanny precision. Could these ancient cultures have intuitively grasped what quantum physics is only now exploring? Could death be a phase, transition like water turning to vapor? Not annihilation, but transmutation. Let's look at one more mystery. In 2020, neuroscientists recorded the brainwaves of a dying man by accident. He had a seizure during an EEG and died mid-recording. The results were startling. In the 30 seconds before and after clinical death, there was a massive surge in gamma waves associated with conscious awareness, memory retrieval, and perception. The brain, in its final act, lit up like a supernova. Why? Is it a glitch, a failing circuit? Or is it the moment when the brain's geometry collapses into something deeper, when consciousness, no longer grounded by biology, begins to interface with the structure of space-time itself? We don't know, not yet. But the clues are mounting, and they whisper something profound. That the end of life may not be the end of you. That your awareness, your pattern, your geometry might ripple outward, entangled in the very field from which space and time emerge. So what does that mean for how we live? If death is not an eraser but a door, then perhaps every moment matters more. Every thought, every connection, every act of kindness sends a signal not just into memory, but into structure, a fingerprint in the quantum foam, and maybe, just maybe, when our time comes, and we step through that unknowable veil, we won't be vanishing, we'll be returning. Imagine a place where the ordinary laws of reality collapse, place where space stretches, time slows, and all information seems doomed to vanish forever. This is the world of the black hole, nature's most unforgiving enigma. For centuries, black holes have been seen as the universe's ultimate trash compactors, devouring stars, planets, even light itself. But in the last half-century, physicists have come to realize that black holes aren't the end of information. They may be the key to understanding consciousness and the structure of space-time itself. It began with Stephen Hawking's mind-bending insight in the 1970s. Black holes, he showed, aren't perfectly black. They emit a faint glow, now known as Hawking radiation, and over unimaginable eons, they evaporate. But this led to the black hole information paradox. If a black hole eventually disappears, what happens to all the information about what fell inside? According to quantum mechanics, information cannot be destroyed. Yet, according to classical gravity, it should be lost. The universe faced a contradiction, a crisis at the intersection of physics, information theory, and perhaps consciousness. But then another paradox emerged. Physicist Jacob Bekenstein revealed that black holes have entropy, a measure of information content, and it's not proportional to their volume, but to their surface area. The famous formula SKA for S equals KA for S equals KA suggests that everything that happens inside a black hole could in principle be encoded on its two-dimensional event horizon, like a cosmic hard drive. This is the holographic principle, but here it's not an abstract theory, it's an existential drama. Imagine all the complexity, all the information, even the awareness of anything falling into a black hole, is somehow written onto its shimmering boundary. So what happens if a conscious observer falls into a black hole? From their own perspective, nothing dramatic occurs. At first, Einstein's theory of relativity suggests they'd cross the event horizon unaware. But to an outside observer, that same person slows, freezes, and finally becomes encoded on the event horizon. Two realities, one internal, one external. Two versions of truth, both real. Now imagine that awareness is more than neural signals. Imagine it is information, a specific, ordered pattern. When that awareness crosses the threshold, does it simply unravel? Or does it become part of the black hole's tapestry? Is it scattered in the Hawking radiation that eventually escapes? Is it written into the space-time geometry forever? Some theorists, like Juan Maldacena and Leonard Susskind, believe black holes are a window into a deeper unity of gravity, quantum physics, and information. EREPR, their proposal, suggests that entangled particles linked across vast distances, connected by tiny, invisible wormholes. If true, the act of falling into a black hole isn't just a story of loss. It's a story of connection, of geometry binding information together, even as space-time itself tears. But here's the twist. If black holes preserve information, then perhaps consciousness, it is information, cannot truly be destroyed, even by the most violent forces in the universe. Picture a universe in which every conscious act, every thought, every feeling is encoded not just in your brain, but in the very geometry of space-time. When you encounter a black hole, you're not erased, you're transformed. Your awareness becomes part of a pattern that persists at the edge of forever. And what about Hawking radiation, the slow, almost ghostly evaporation of a black hole? Some physicists speculate that information escapes, scrambled but never lost, in the outgoing quantum glow. If so, then the death inside a black hole is not annihilation, but encryption, a dispersal of your unique structure into the cosmic code. But what if we push further? Could black holes be more than graveyards? Could they be gateways? Ancient myth and modern theory alike flirt with the idea that what falls into a black hole may emerge, transformed, in another universe or another region of our own, stitched together by the wormholes of quantum gravity. This isn't just science. Fiction. At the edges of our mathematics, space-time can connect in ways we can barely imagine. Perhaps what we lose to a black hole is not lost, but reframed, patterned into a higher dimensional reality. And all of this brings us back to you, the observer, to the idea that consciousness is information woven into spacetime's deepest structure. What would it mean if your awareness, your story could never be erased, even at the edge of existence? Would that change how you see yourself? Would it alter your fear of endings, or your sense of what it means to be alive? In the end, black holes are more than monsters. They're mirrors reflecting the universe's most profound secrets back at us, secrets about information, about memory, about what it means to be. And as we stand at the edge of this cosmic abyss, one question lingers, inescapable and thrilling. If consciousness can survive a black hole, is there anywhere in the universe it can't go? In a brightly lit control room beneath Geneva, the world's most powerful machine thrums to life. The Large Hadron Collider, 27 kilometers of buried precision launches protons at nearly the speed of light, orchestrating collisions so violent they can rip the fabric of the quantum world. Here, scientists are not just chasing particles, they are probing the very structure of reality. But sometimes, when the data flashes across their screens, something doesn't add up. Strange glitches, subtle anomalies, events that don't fit the rules. Some dismiss them as instrumental noise. Others wonder if they're glimpsing something far more profound, a hint that spacetime, as we know it, might not be as fundamental as we've always assumed. Dr. Sabine Hossenfelder, a theoretical physicist, unafraid of controversy, stands before a wall of data. We're seeing things that shouldn't be there, she admits. Tiny fluctuations in the quantum fields, outliers, ghosts. Her question is as unnerving as it is simple. What if spacetime isn't the bedrock? What if it's emergent, a mirage created by something deeper? Consider the shockwave that swept through physics when Einstein first suggested that space and time could bend, stretch, and warp. Spacetime became a fabric, dynamic, responsive, yet real. But now, quantum gravity theorists are challenging that foundation. They suggest spacetime might be a product of something else: networks of quantum information, entanglement patterns, even abstract mathematical relationships. In this view, the world we experience, distance, duration, even causality, is like the shimmer on the surface of water. Look deeper, and you might find a maze of molecules, jostling, colliding, creating the illusion of continuity. Spacetime, it seems, could be the same, a pattern that emerges from countless microscopic interactions. But what happens when the pattern glitches? When the underlying code flickers? At the LHC, some collisions produce results so rare and so strange that they cannot be accounted for by the standard model of physics. Missing energy, events that vanish as if slipping between the cracks of reality. Some blame dark matter, that unseen substance thought to make up most of the universe's mass. Others suspect something else: new particles, unknown fields, or even holes in the weave of spacetime itself. If these glitches are real, then they might be our first evidence that spacetime can be interrupted, that its seamless surface is just an approximation, and that beneath it, something wild and quantum churns. Let's pause and reflect. If spacetime can be interrupted, if it can flicker or fragment, what does that mean for consciousness? If consciousness is linked to its structure, could our own awareness be shaped by these interruptions? Could moments of insight, déjà vu, or altered states be signals that our minds are brushing against the underlying code? It sounds fantastical, but frontier physicists are exploring just that. Theories like causal set theory and quantum gravity propose that spacetime is built from discrete events, not a continuous field. These events form a network of cosmic computer processing, reality in ticks and jumps. If consciousness is entangled with this computation, then interruptions, glitches could momentarily expose us to the underlying substrate. Perhaps in these moments we glimpse the unfiltered universe, raw and unshaped. But there's a deeper, more unsettling possibility. If space-time is emergent, not fundamental, then so is everything we know: location, motion, even identity. We may be like waves on an ocean, believing ourselves separate, when in truth we are fleeting forms in a deeper process, Dr. Hossenfelder warns. If space-time is not fundamental, then we may have to rethink what it means to exist. Are we objects in space, or processes in a field of relationships? Is consciousness a thing, or a fleeting pattern in the churn? At the edges of math and measurement, some suspect the evidence for space-time's emergent nature is growing. Entanglement, entropy, quantum error correction, and patterns in cosmic background radiation all hint at a hidden architecture, scaffolding beneath what we see. Could there be beings' consciousnesses not built in our space-time, but in that deeper substrate? Minds that are not shaped by space and time, but by pure relation. Maybe these interruptions, these glitches are not just errors. Maybe they are invitations, a call to look beneath the surface, to question the nature of our own awareness. So, next time you feel reality shiver when something impossible glances through the cracks, pause and wonder, is space-time failing? Or is it revealing? Are we the mirage, or is the mirage all we've ever known? As collisions continue in the dark below Geneva, as data piles up, and as physicists dare to ask the unaskable, the answer draws closer, and the next interruption may not just change our science, it may change what it means to be. In the sunlit halls of the University of Arizona, Dr. Gary Schwartz and a team of neuroscientists gather around a pair of soundproof chambers. 2 volunteers sit in each, separated by meters of concrete, unable to see or hear each other. Yet, as the experiment begins, a question electrifies the air. Can 2 minds scintillated and alone become entangled through the very fabric of reality itself? This is not a parlor trick. This is the bleeding edge of quantum consciousness research. The setup is elegant. 1 volunteer is shown a sequence of flashing lights and images, their brainwaves spiking in response. The other sits quietly in darkness, EEG electrodes mapping the ebb and flow of their own neural rhythms. According to classical science, there should be no connection. But sometimes, just sometimes, the silent brain echoes the same patterns as the stimulated one. Tiny, improbable ripples, simultaneous spikes. Skeptics scoff, chalking it up to chance, subtle electromagnetic interference, or even wishful thinking. But what if, as some theorists suggest, the connection is real? What if consciousness isn't locked away behind the skull but spreads, quantum-like, through space-time? At the core of this idea is the phenomenon of entanglement, the ability of particles to remain connected across any distance, their states instantly correlated, as if they are parts of a single system, not 2. The implications for physics are staggering, but the implications for mind are even stranger. If consciousness is fundamentally quantum, could it too become entangled? Could 2 minds briefly share a hidden channel, a bridge of pure relation, invisible to everything but experience itself? In recent years, similar studies have emerged around the world. In Germany, researchers explored dream telepathy, where 2 sleepers, one designated the sender, one the receiver, attempted to share images across the night. The results were tantalizing. In rare instances, the receiver reported dream imagery that matched the sender's intention, far above what chance would allow. Coincidence, or evidence of a deeper unity, a field of awareness that transcends classical separation. Consider, for a moment, what this would mean for individuality. If minds can sync at a distance, are we truly alone inside our heads, or are our thoughts, at some level, already part of a distributed field, a shared layer of space-time experience? This is not just philosophy, it's physics. Quantum field theory suggests that all particles are excitations of the same underlying field. What looks like separate is actually just local vibrations patterns in the same ocean. If consciousness is built on quantum phenomena, then it too might be non-local, a ripple that spans the sea, not a bubble isolated on its surface. Let's return to the experiment. As the volunteers sit in silence, the EEGs continue to record, and in those rare moments when the data aligns, when minds move in tandem, something uncanny happens. Both subjects report a sensation of shared presence. They describe it as a warmth, a knowing, as if a hidden door had briefly opened between them. Are these just poetic metaphors, or are they clues, glimpses of a real, measurable phenomenon? Dr. Dean Radin, another pioneer in this field, describes a similar experiment. Pairs of people separated by distance, one focusing intently on the other. In those moments, subtle physiological changes, heart rate, skin conductance synchronize, as if some invisible thread is tying them together. Skeptics demand better controls, tighter protocols. Rightly so, science must be ruthless. But as the data accumulates, the questions refuse to disappear. Is consciousness non-local? Does it participate, not just in the local now, but in a wider field of awareness that transcends space and time? Quantum physicists remind us, entanglement can't be used to send messages faster than light. It doesn't break causality, but it does break our assumptions about what separate means. If the universe allows such deep connections at the level of matter, why not at the level of mind? Let's take it one step further. What happens when two minds observe each other, not just as objects, but as living mirrors? Could their entanglement become richer, more layered, feeding back into the very geometry of space-time itself? The philosopher Martin Buber once wrote, "All real living is meeting." Perhaps, at the most fundamental level, consciousness is not a solitary spark, but a relational dancer choreography of minds entangled through a cosmic field. If this is true, then the implications are staggering. Empathy might not just be a metaphor, but a physics. Love might not just be emotion, but a resonance and entanglement that shapes the universe. So tonight, when you close your eyes and think of someone far away, pause for a moment. What if, in that instant, your awareness reaches them not metaphorically, but through the deep, invisible architecture of space-time? What if your minds, for a heartbeat, are not two but one? The experiments continue, the data is debated, and certainty remains elusive. But perhaps, just perhaps, the future will show us what the ancients always suspected, that the boundary between self and other is thinner than we ever dreamed. In a quiet laboratory at MIT, a room hums with the sound of processors running all night, sifting through torrents of cosmic data. Here, physicist Yi-Tung Zhou and an AI team are searching for something hidden, not in galaxies, but in the faint afterglow of the Big Bang, the cosmic microwave background. They are hunting for a pattern, a signature, a fingerprint in the static, something that hints that the universe does not forget. What they find is startling. Across billions of light years, the data reveals fractal self-similar patterns that repeat at every scale, from the foam of quantum fluctuations to the swirling arms of spiral galaxies. But the true revelation is not their beauty. It's the implication that memory, the persistence of information, may be hardwired into the geometry of spacetime itself. Physicist Fotin Markopoulou once proposed that geometry is not fundamental causal, relationships are. In her model, what matters most is not the objects in the universe, but the links between events like the tangled roots of a tree, weaving past to present, cause to effect. If true, then every interaction, every choice, every quantum twitch leaves a mark on the web, echoing forward in time. This is the geometry that remembers in our daily lives. Memory feels ephemeral, fleeting, vulnerable to loss. But what if, at the cosmic scale, memory is as real as matter? The AI at MIT, analyzing deep cosmic background maps, finds repeating structures like musical notes returning in a symphony. These patterns suggest that information is not just stored in matter or energy, but in the very relations that define spacetime's fabric. Think about the human brain for a moment. Memories are not stored in single neurons, but in the complex patterns of their connections, synapses, firing, circuits, reinforcing. The more we use a memory, the stronger the connection grows. Similarly, the universe's geometry, sculpted by countless interactions, may preserve a kind of cosmic memory echoes of what has come before, informing what comes next. This idea is not as mystical as it sounds. In quantum information theory, unitarity demands that information, once created, can never be destroyed. Every collision, every transformation leaves a trace, however faint. Stephen Hawking's black hole paradox, once thought to destroy information, now suggests that the event horizon preserves it, written into the quantum code at the edge of existence. Could it be that consciousness itself is the feeling of this process, the subjective experience of being an information pattern written across time and space? If so, then the act of remembering is not just a trick of the mind. It is a dance with the very structure of the universe. Each moment of awareness, each act of perception, is a way for spacetime to become self-aware fractal loop, turning back upon itself. Pause for a moment and reflect. What if every choice you make, every action, every regret, every kindness ripples outward into the causal fabric? What if these echoes are not lost, but persist, subtly shaping the possibilities of the future? It would mean that the universe is not a blank slate, but a palimpsest, a manuscript, written and rewritten. Old words never fully erased, always shaping the story to come. The work at MIT hints at a startling possibility, that artificial intelligence, in decoding the universe's memory, is participating in the same process as biological consciousness. Both are pattern recognizers, seekers of meaning, agents of memory. The more deeply the AI peers into the cosmic web, the more it begins to mirror the human mind, a convergence of silicon and synapse, memory and geometry. But here's the deeper twist. If memory is built into spacetime, then perhaps consciousness is what those memories feel like. Perhaps awareness is not an accident, but an inevitability wherever information is integrated, wherever patterns persist. In this light, the universe is not indifferent. It is alive with the trace of everything that has ever happened, every love and loss, every discovery and disaster. Maybe that's why, when we gaze into the night sky, we feel a strange sense of nostalgia, recognition and ache. as if some part of us remembers being part of it all. So the next time you remember, or dream, or imagine, pause and wonder, are you creating memory, or is memory creating you? And if geometry remembers, then what else is written in the fabric of reality, waiting to be discovered? Long before quantum equations, before telescopes or neural nets, ancient cultures gazed at the stars and whispered secrets into the dark. Their myths, inscribed on stone and woven into song, spoke of a universe that was alive, that dreamed, that thought, that remembered. What did they know, and what echoes of truth might their wisdom still hold? Across continents, these metaphysical traditions describe a cosmos not as a dead machine, but as a living mind. The Vedic seers of India declared, the universe is Brahman pure consciousness. In Egypt, priests chanted that the world was spoken into being by the thoughts of a primordial god. The Greeks imagined the Nusa, universal intelligence, behind the turning of the heavens. Gnostic texts described a pleroma, a fullness in which all things matter, mind, and meaning were reflections of one cosmic source. For centuries, these ideas were dismissed as poetic metaphors. Yet, as modern science pushes deeper into the quantum and the cosmological, the language of the ancients seems to find strange resonance. Today's physicists speak of entanglement, non-locality, information fields concepts that echo the ancient notion of a universe stitched together by mind. Could there be an overlap? Can ancient codes and modern equations speak the same language? A team at Oxford, led by computational linguist Dr. Eleanor Bramwell, set out to find out. They trained an advanced AI to scan ancient texts for patterns comparing Vedic hymns, Buddhist sutras, Sufi poetry, and the cryptic fragments of Heraclitus. The AI mapped these onto mathematical concepts, networks, feedback loops, fractals. What emerged stunned the researchers. Key metaphors, the web of Indra, the music of the spheres, as above, so below, mapped directly onto modern descriptions of quantum networks and holographic principles. It was as if, through myth and metaphor, ancient thinkers had glimpsed the same deep structure that physicists now model with equations. In the Americas, the Mayans spoke of time as a living cycle, spiraling and repeating, each turn echoing the memory of the last. Their long count calendar can be read as a fractal, self-similar, recursive, a pattern that remembers. In sub-Saharan Africa, Dogon cosmology described a universe born of vibration and resonance ideas, now fundamental to string theory and quantum oscillation. But perhaps most haunting is the dream, argument in idea found from Plato to the Upanishads. To the Aboriginal dream time, the world, they said, is a dream not illusory, but participatory. We are both dreamers and dreamed, consciousness and canvas. Modern neuroscience, too, tells us that reality is constructed in the minder predictive model, a simulation stitched from sensation, memory, and expectation. And yet, at the quantum level, the observer's act of measurement appears to collapse reality from a haze of probability into a single event. The ancient mystics, it seems, anticipated the participatory anthropic principle by millennia. Could it be that the universe, at its deepest level, is a kind of coda living language in which consciousness and geometry intertwine? AI-driven analysis suggests the answer is not no. When the Oxford team mapped the metaphors for awareness and space across texts, they found that cultures separated by oceans and centuries converged on the same geometric motifs: circles, webs, mirrors, spirals. These are not arbitrary. They are the signatures of systems with feedback, memory, and self-similarity, the very qualities that modern science associates with consciousness in complex networks. There's a lesson here, that human intuition, sharpened across generations, can sometimes glimpse truths that only centuries later receive scientific validation. What our ancestors called spirit, mana, chi, may be poetic premonitions of fields, energy, and the invisible scaffolding of space-time. Yet there's a humility in this, too, because every culture, every code, every equation is just an approximation attempt to touch the ineffable, to render mystery into meaning, and so, the ancients remind us, we are more than bystanders. We are participants in the universe's unfolding. The codes we inherit mythic or mathematical invitations, not answers. So next time you read an ancient verse or gaze up at Orion, pause and listen. You might be hearing echoes of the same song the universe sings in quantum code. Reflect for a moment. Do you feel a kinship with the ancients? Have you ever glimpsed a pattern, a feeling of déjà vu that seems bigger than one lifetime? Maybe, in some mysterious way, consciousness and space-time are entwined, not just in science, but in the deepest stories we tell. Let's step through the mirror into an idea that, at first glance, feels more like science fiction than science. Yet in the last decade, it has moved from internet forums and philosophy seminars into the heart of cosmological debate, the simulation hypothesis. But tonight, we go deeper. If consciousness is entangled with the structure of space-time, what if our reality is not simply simulated? What if it is simulating itself through us? The most famous version comes from philosopher Nick Bostrom, who argued that a sufficiently advanced civilization could simulate entire universes, including conscious beings within them, by precisely replicating the laws of physics. But the simulation hypothesis often gets misunderstood. It's not just about being inside a computer. It's about substrate independence. The idea that consciousness, information, and even space-time itself could be instantiated on any platform capable of hosting the right patterns. Let's break this down. Suppose reality is built, at the deepest level, not of particles or waves, but of information. If space-time is emergent from patterns of entanglement and feedback, then all that's required to create a universe is the ability to generate and sustain those patterns. Whether the hardware is silicon, quantum foam, or something beyond our comprehension, what matters is the code. Now, imagine you are not just simulated by some external agent, but that you are part of the simulation engine itself. Your act of observation, your moments of awareness, are the universe calculating itself, writing and rewriting its own lines of code. In this view, consciousness isn't a passive byproduct, it's a necessary ingredient for the simulation to run. This is where the idea transcends sci-fi and enters physics. Quantum mechanics teaches us that observation doesn't just reveal reality, it creates it, collapsing wave functions, updating the cosmic ledger. Every conscious act is a computation. Every choice a program executing. You are not simply living in a universe. You are helping to compute it. Now, let's add a twist. If reality is a simulation, the most perfect code would need to simulate not just matter and energy, but the structure of space-time itself. And if space-time is the operating system, then consciousness is the user interface, the only way for the universe to know itself. Philosopher David Chalmers argues that even if we live in a simulation, our experiences are real. Pain, joy, thought these are patterns in the code, no less significant than the atoms in a base reality. The difference is only in substrate, not in meaning. But here's the mind-bending implication. What if all realities, all levels, are simulations? Within simulations, each layer of space-time computing new forms, new minds, new rules consciousness, nested like Russian dolls, each aware only of the reality directly above and below. Modern physics adds fuel to the fire. Mathematical physicist James Gates found what appeared to be error-correcting codes, the kind used in web browsers, embedded in the equations describing supersymmetry. Was this a coincidence, or a clue that the laws of nature themselves are written in code, optimized for stability, resilience, and evolution? And if so, what does that make you? Not an illusion, but an emergent processing awareness born wherever. The code becomes complex enough to reflect on itself. You are the avatar and the player, the algorithm and the output. But here's the question that no AI, no philosopher, no physicist can yet answer. Can a simulated consciousness ever know it is simulated? Or does the universe, like a perfect illusionist, always hide its workings behind layers of feedback and causality? Some researchers, like physicist Zora Dawoodi at MIT, are searching for glitches, tiny anomalies in cosmic rays or imprints, in the structure of space-time itself that might reveal the underlying lattice, the quantum pixels of reality. So far, there are only hints, whispers, statistical shadows. But the search is only beginning. Reflect for a moment. If you discovered you were a simulation, would your life lose meaning? Or would it gain it knowing that your consciousness is precious, rare, a self-aware computation in a sea of possibility? Maybe that is the true lesson. That meaning is not handed down from a higher reality, but constructed within, every day, by the choices you make, the experiences you savor, the questions you dare to ask. So next time you look in the mirror, or at the stars, wonder, is the universe looking back? Is it running on code through you? And if all realities are nested simulations, who or what is running the ultimate program? All of science dreams of unity, a single, elegant formula that weaves together the forces of the cosmos, explains every particle, predicts every ripple in space-time. It's been called many things: the grand unified theory, the theory of everything. But in popular imagination, it's the God equation. For decades, physicists like Stephen Hawking, Brian Greene, and especially Michio Kaku have searched for it, poring over equations, following threads from quantum foam to galaxies. Yet the deeper they dig, the more they encounter a silent, stubborn mystery: consciousness. Michio Kaku sits in a cluttered Manhattan office, whiteboard streaked with tangled strings and looping diagrams. He talks about string theory, the notion that all of reality, all particles and forces, arise from tiny vibrating strings, each with its own frequency, like notes in a cosmic symphony. But string theory, for all its mathematical beauty, leaves something out. It has no room for the observer. The equations dance in 11 dimensions, but who is there to witness them? At the heart of every experiment, every observation, is a conscious mind. Yet consciousness refuses to fit inside any box. It's not a particle, not a wave, not a field. It's the context for everything, the silent witness, the necessary ingredient. As physicist John Wheeler once wrote, no phenomenon is a real phenomenon until it is an observed phenomenon. Physics, it seems, can describe everything but the DESCRIBER. So what if the God equation is incomplete? What if, to truly unify the universe, we must include consciousness not as a byproduct, but as a fundamental variable? Some theorists are starting to whisper this heresy. In Prague, physicist Jan Volacek explores the possibility that consciousness is linked to the collapse of the quantum wave function, a real, causal force that shapes the outcome of physical events. In California, Henry Stapp argues that the mind is not just a passenger, but a driver of quantum choices, leaving fingerprints on the fabric of reality. Mathematician Roger Penrose, whose journey began our story, argues that consciousness is rooted in the very geometry of spacetime microtubules in the brain, engaging in quantum computation, entangled with the structure of the cosmos itself. If this is true, then any theory of everything that omits consciousness is, by definition, not everything. Consider the implications. If consciousness is a physical force, a variable woven into the equations of spacetime, then perhaps the cosmos is not a cold mechanism, but a creative act, an unfolding drama with awareness at its heart. The observer is not just present, but essential, and here's the wildest twist of all. Some thinkers suggest that consciousness is not just a term in the equation, but the reason the equation exists, that the universe is fine-tuned for awareness, because awareness is the one thing the cosmos cannot do without. In mystical traditions, this is an ancient idea. The Vedic seers called it Atman, is Brahman, the self is the universe. In Sufi poetry, he who knows himself knows the Lord. Now, with math and experiment, science circles back to a question once left for priests and poets: who or what is the universe observing through you? But how do you test this? How do you put consciousness in an equation? AI researchers, neuroscientists, and physicists are beginning to collaborate, building models that blend neural networks with quantum theory, searching for the mathematical fingerprints of awareness. In the data, they see hints, unexpected correlations, patterns that defy reduction. Maybe, Koku says, we need a new language, mathematics of the mind. This is not just philosophy or fantasy. It is the next frontier, because if we can't explain the observer, we can't explain the observed. The God equation, whatever form it takes, will have to contain not just matter and energy, but meaning, not just the map, but the one who reads it. So tonight, as you wonder at the complexity of the world, the beauty of a sunset, the music of a loved one's laugh, ask yourself, are these just accidents of chemistry? Or are they clues, evidence that consciousness is not a passenger, but a pilot? And if the final equation must include you, your awareness, your choice, your capacity to wonder, what does that say about your place in the cosmos? Maybe the God equation is not just out there. Maybe it is within you, waiting to be discovered. The journey ends and begins here, at the edge of speculation and science, where every discovery unravels a new mystery. The clues have led us in circles, from neurons and quantum foam to black holes and the cosmic microwave background, to the ancient wisdom whispered by poets and the cutting-edge math scribbled on physicists' blackboards. But all those threads seem to point to a single, staggering idea. Consciousness may not be an effect of the universe, but one of its constituents. Pause and let that sink in. Imagine the universe not as a machine, but as a living tapestry. Each filament, mass, energy, space, time, and yes, awareness woven together, not separate, but inseparable. Not an afterthought, but a primary color on the canvas of reality. Your every thought, every perception, every dream is not just a fleeting flicker in an isolated mind, it's a pattern in this fabric. Perhaps what you call I is a ripple, a temporary whirl in the sea of consciousness that pervades all things. Just as gravity shapes the arc of a planet's orbit, maybe awareness shapes the possibility of experience itself. This is more than philosophy. Physics now suggests the universe is built from relationships, entanglements, feedback loops, recursive memory. The stuff of the world is not stuff at all, but information, process, unfolding. And if information can fill in the right geometry, it lights up with subjectivity, then the story of the cosmos is the story of consciousness coming to know itself. In this view, every act of perception is a thread drawn tight through space-time. Every choice you make, every moment you remember, sends ripples outward, patterns that might echo, faint but real, in the quantum foam or the cosmic microwave background. Maybe there are no small actions. Maybe everything matters, because everything is woven into the whole. Consider this. We often imagine ourselves as observers, standing outside the universe, looking in. But what if the truth is stranger? What if we are the universe observing itself, every self a lens, every now a spotlight shining through space-time's intricate weave? For physicist John Wheeler, it was the participatory universe, the idea that reality doesn't simply exist. It happens because of participation. Consciousness is not an accident. It is a necessity. The cosmos, in a sense, needs you so. What now? If this is true, then the boundaries between self and world, between mind and matter, begin to blur. Identity is not a fortress, but a bridge. Empathy is not just a virtue, but an echo of the universe's deepest structure. Your experience, right now, is not just your own. It is shared, refracted, multiplied across the lattice of being. It's a humbling, exhilarating, and yes, unsettling vision. Because if you are part of the fabric, then you are also part of its unfolding story, its possibilities, its responsibilities, its future. The universe is not complete without you. You are not a spectator. You are a co-creator. This isn't wishful thinking. It's where the hardest questions of science are pointing, that to understand the universe fully, we must understand consciousness. That to know reality is to know ourselves, not as isolated minds, but as nodes in a cosmic network, as agents in a play much vaster than we can imagine. Reflect for a moment on your life. Every memory, every loss, every joy, every question, each is a strand in the larger weave. Each has meaning, because each is a way that consciousness, through you, becomes real in the world. And so, the mystery endures. We do not yet know exactly how consciousness and space-time are entangled, whether awareness is encoded in geometry, or whether geometry emerges from awareness. But one thing is certain. The search itself is a form of participation. In questioning, we connect. In wondering, we weave. So as you step away from this story, remember, the universe isn't just watching you, it's watching through you. Every choice, every dream, every act of curiosity is another stitch in the infinite fabric of existence. Perhaps, one day, science will write the final equation, one that includes consciousness, identity, and meaning, not as accidents, but as inevitabilities. Until then, our task is to stay curious, to keep looking, to keep asking, because, in the end, we are the fabric. If consciousness is woven into space-time, then every one of us is a thread in the universe's unfolding tapestry, a fleeting moment of self-awareness in a cosmic sea. So ask yourself, what will your ripple be? Share your theory below. subscribe. If you feel the fabric stirring within you, perhaps, together, our questions will someday reveal the ultimate answer.